Hi, it's Valentine from Simplistic. In this problem, we're going to take a look at how to determine the half-life of a drug if a certain amount of it, 25% in this case, decomposes in 20 minutes. And the question says to assume first-order kinetics. All right, so to assume first-order kinetics, we should know that the expression for the integrated rate law, first order rate law, is given by ln of a t is equal to minus k t plus ln of a naught, where a naught is the initial concentration, at is the final concentration, t is the time, and k is the rate constant. All right, so the next thing that we need to do is figure out what is given to us in the problem. So I'm going to put that in green out here on the right. So A naught is nothing but the initial concentration, so we can keep that as is. Since no quantity is given to us in the problem, we're just going to keep A naught is equal to A naught. Now, AT, the final concentration, is going to change because what it's telling us in the problem is that the half-life of a drug that we have to determine is telling us that 25% of that drug decomposes in 20 minutes. And what that means is that if 25% of it decomposes, that means 75% of it is still left. So that is going to be AT. So AT is equal to 0.75 of A naught. So now we have A naught and AT. The next thing we need to figure out is the time. The time is given to us as 20 minutes. So T is equal to 20 minutes. And then if we plug this, and this into this equation, the only thing we'll have left to determine is the rate constant, K. So let's go ahead and do that and see what we get for K. So we have ln of A, I'm just going to replace AT with 0.75 A naught, and then K I'm going to keep as is, and then time is going to be 20 minutes plus ln of A naught. Now I'm going to take this A naught, I'm going to put it on this side. So I get ln of 0.75 A naught minus ln of A naught is equal to minus K times 20 minutes. Now let's recall the rule of logarithms. If you have ln of A minus ln of B, that is equal to ln of A over B. So that's what we're going to apply out here. So we have ln of 0.75 A naught over A naught is equal to minus K times 20 minutes. Now A naughts cancel out. Excuse me. And then what you end up having is ln of 0.75 gives us essentially minus 0.28768. And the numbers go on, but we don't need any more digits. That is equal to minus K times 20 minutes. So now if you have to solve for K, we can go ahead and cancel out those negative signs. So we're going to get K is equal to 0.28768 over 20 minutes, which is equal to 0.14384 per minute. So that is the value of the rate constant. Now, we're not applying the rules of significant figures yet because we're just trying to keep as many decimals as we can because we'll round the answer later on, okay? So then the next step is to calculate T half. So T half is actually equal to, I'm going to just write this, I'll just move this a little to this side. T half is equal to 0.693 over K. That is the expression for the half-life of a first order reaction. So all we have to do is replace the K with what I got out here. It is 0.14384 per minute, and that equals 48.1785 minutes, which rounds to 48 minutes. And there you have it. That's the answer. I hope that made sense. Thank you for watching.